So I'm going to mute everyone now. So I will only approve the presenter to unmute himself. And as the program progresses, I will do accordingly. So very good evening to one and all present. We have a very important topic for today's webinar, that is stress and heart rate variability signal processing, that is HRV signal processing. And at this very outset, I would like to thank our resource person for giving his valuable time among this pandemic situation. I would like to introduce the speaker for today's session, Mr. Debanjan Borthakur. He's currently a master's student at McMaster University, Canada, in psychology and neuroscience and behavior department. Previously, he has studied at the University of Rhode Island for MS in interdisciplinary neuroscience. He has done his BE at JIST Jorhat in electronics and telecommunication. His research interests are biosignal processing, health psychology, neuroscience. He has been awarded a few scholarships as well. In 2018 and 19, he was awarded with the NCERS Create Graduate Award in Complex Dynamics. In 2016, he was awarded the sponsorship by the George and Annie Ryan Institute for Neuroscience. Now, coming to today's topic, heart rate variability, HRV, is a physiological measurement that can help to monitor and diagnose chronic diseases such as cardiovascular disease, depression, and psychological stress. HRV measurement is commonly extracted from the electrocardiography, that is ECG. However, ECG has bulky wires where it needs at least 3 surface electrodes to be placed on the screen. The heart rate signal are processed first using Fourier transform and then is applied to wavelet transform. So now I would like to invite our resource person to carry forward the session. Debanjan.
Thank you, Jesif. First of all, thank you everyone for having me here today. I would like to thank Dr. Sakuntala Laskar Madam for giving me this opportunity. Also, many thanks to Jesif Ahmed for organizing this event. I'm really feeling honored and also delighted. And I will look forward to interacting with everyone during the talk and also after the talk. So I will. So my introduction has already been given by Jesif. So right now I'm at McMaster University, and we are doing research on developing different techniques for stress reduction. So music can be used for reduction of stress as well as different breathing techniques. So my focus is on breathing techniques right now. How can we effectively use breathing techniques to reduce stress? So the lab in which I am in, so they do a lot of studies on music mostly, like how music affects our mind, and why we move with the music. So they record like our activities using motion capture and all that. So okay, so I will share the slides now, so we can directly go to the discussion on heart rate variability and stress.
I'll just interrupt you for a few seconds. If the participants has any questions to be asked, you can put the questions in the chat box. Thank you.
Okay. So is this visible, my screen?
Yes, you can full screen.
Okay. Okay, great.
Yes, great.
Okay, so today's topic is stress and heart rate variability signal processing. This is a very interesting topic, and I'm also thinking of going in this direction of health psychology. Originally, I was from electronics. We also do. I do mostly signal processing, so I'm using the skills that I learned in my engineering days, but we're applying it in different domains mostly. Okay, so let's see what is actually stress. The formal definition of stress is: stress represents physiological responses in presence of stressor causing an upset in the homeostasis. So we have something called stressors. Like the stressors can be, it can be an acute injury, it can be illness. Just 1 second. Okay.
Sorry, I will mute myself.
No, it's okay. Yeah, and it can be career pressure, right? So so you're a student, so you have exams and all that, so you're always stressed. And it can be environmental also. Now we have the corona, right? The coronavirus, so we are all stressed. We don't know what will happen. Like here we are under lockdown and we cannot go to lab. We have to work from here. And what about the next pandemic comes next year? What will happen? So there are a lot of uncertainties, and those things, can be considered as a stressor. So when we're exposed to stressors, so there are a lot of physiological responses that takes place, and this process is called actually stress. And the stress has both bad and good sides. So it's not that it's always bad, because I will at the end we will discuss how why actually we have stress. It's an evolutionarily inherited mechanism actually, so that we can adapt to the environment. Just imagine, like 500 years ago, or maybe, like 1,000 years ago, you are living in a cave and a tiger comes in front of you. You have to run, right? So this is a mechanism that actually helps to survive. So this is very interesting. Okay, so this is the definition of stress. So we know that we have stress, so we need to reduce stress. So I will go into like the biochemistry of stress a little bit. So what are the consequences of stress response? So we know, like when we have stress, so a lot of hormones get released. Like one is the adrenaline mostly, and another is the cortisol. So what actually happens, there are some negative effects of stress. You can feel fatigue, you can have metabolic disorders, you can gain weight, you can have insomnia, and it can also lead to depression. That's the low mood, your mood swings and you're always at a low mood state. So yeah, these are some of the consequences of stress. Yeah. Okay, so this is what actually happens when we have stress. So we have a stressor, as I explained before. So the stressor can be, like your exam pressure, or it can be any environmental stressor, like, like I like giving examples even from my state, Assam, what's going on right now. We have a fire broke out in Pakistan, like think about those people. They are under constant stress. What will happen, So those stressors, what it does, so we have an area in the brain called hypothalamus. So that hypothalamus actually triggers the adrenal glands that are at the top of our kidneys. So it releases adrenaline and also cortisol. So adrenaline is mostly responsible for rapid responses, and cortisol is much slower. And when we have a lot of cortisol, then it again triggers the brain, and the stress reaction shuts down. So adrenaline is important because it actually makes your heart pump faster. So you have, like, definitely if you have a tiger in front of you, you have to run. So your heart has to pump fast. So all these things actually happen when we have stress. Yeah, so we have like the central nervous system and the autonomic nervous system. So the autonomic nervous system actually controls the autonomic functions, like our breathing, our heart rate, and all those things. So here, let me explain. So as I mentioned, we have the hypothalamus, right? So, and we have two different pathways that actually connects the heart. I'm considering the heart, but there are other organs that are also affected when we have stress, because we are discussing the heart rate variability. So that's why I will focus mostly on the heart. So we have two different pathways that are connected to the heart. One is the parasympathetic pathway, that we have a nerve called vagus nerve that comes from the brainstem, and we have from the spinal cord we have the sympathetic nerves. So the sympathetic nerve actually is responsible for the fight or flight response. So if you have a tiger, you have to run away. So that's your, so when you see a tiger, your sympathetic response, dominates. Parasympathetic response, like when you are relaxing mostly. So when the sympathetic response is dominant, your heart rate will go up, your respiratory rate will go up. And then we need to, somehow control the heart rate, definitely. So then the parasympathetic nervous system kicks into action. And this vagus nerve is very, it's actually famous. You can Google, like they call it vagal control. Like if we can control this vagus nerve, actually we can control most of our autonomic rhythms. So the parasympathetic nervous system mostly acts directly from the brainstem, so you can see their direct connection. And the sympathetic one, actually, the connections are from the spinal cord. And there we have this ganglia. These are actually relay stations where two different neurons synapse. So, and also in the heart, we have certain cells which actually fires automatically. They are called like sinoatrial node and atrioventricular node. I think some of you might know about this. So actually, these signals from the brain innervate the muscles of the heart. They send the signal to the heart, and the heart then slows down or it starts to beat faster. Yes, this is what actually happens when we are actually stressed, or when we, when we're facing a stressful event. Okay. All right. Because we're talking about the heart, so we have two main neurotransmitters that are responsible for pacing the heart and slowing down the heart. So acetylcholine is mostly for slowing down the heart. So when you have more acetylcholine production, then it slows down the heart. At the same time, when we have more noradrenaline, it actually increases the heart rate. So these two are the main neurotransmitters that are responsible for controlling the heart rate. It can go up or it can go down. Okay, yeah, I also put this slide because this cortisol is one of the major stress hormones. So I will just read it loud. So this hormone is released during times of stress, increasing heart rate, blood pressure, blood glucose, respiration, and muscle tension in response. It also temporarily shuts down the body systems that are not needed in the face of crisis, such as digestion and reproduction. This is very interesting because when we are facing a challenge, right, when we are confronting a stressor, then we don't need to think about digestion or reproduction. Our main goal is to, cope up with the situation somehow. So that's why all the energy is actually devoted to that task, and all other functions are shut down. This is actually what happens. Let me check my battery. Oh, just give me a few seconds. I will connect the adapter.
Sure, no problem. You can take your time.
Sorry for the interruption. Are you still hearing me?
Yeah.
Okay, great. Yeah, so this is all about cortisol. This is one of the major stress hormones. In my study, I'm not measuring it, but usually in most of the studies that deals with stress, they measure the cortisol. It can be measured through your saliva, or I think from your hair also. We can know, how much cortisol you have in your blood. If you have more cortisol, you are more stressed, something like that. So, yeah. Okay, so now let's discuss about how to reduce stress, right? So we have the stress. So it's good sometimes, but it's not good if it is a chronic stress. So we have to somehow reduce stress. So what about slow breathing? So this is what actually I am doing right now. So I'm using the intervention of slow breathing to reduce stress. So I will discuss like how actually it helps reduce stress. Okay. So I have a couple of bullet points here. I will just read them aloud. So why slow guided breathing? So I will discuss what it is. I just want to let you know like why actually we are using slow guided breathing for reduction of stress. So these are actually previous findings, like deep abdominal breathing encourages full oxygen exchange. So when we breathe, when we take a deep breath, our oxygen exchange is actually optimized in the lungs. It can slow the heartbeat and lower or stabilize blood pressure. And this is actually already been established proof. If you know how to breathe, it will actually slow down the heartbeat. Helps reduce stress. Yeah, so this is also one of the previous findings. Okay, so before proceeding, I need to explain a concept to you. There is something called respiratory sinus arrhythmia. So here, what you can see, when we inspire, when we inhale, our heart rate goes up. So let's assume this is the heart rate. So your heart rate is like, say now 65, then it goes up 66, 67, like that. And then it again drops when we exhale. And this pattern is followed. So there is a direct relationship between your breathing pattern and your heart rate. This interaction is quite complex and quite non-linear. Still, I'm trying to understand. It's very interesting. So this is called respiratory sinus arrhythmia. So your respiratory rate actually affects your heart rate. Okay. Okay. So then comes the question: why heartbeat synchronize with respiration? As we said here, we inhale, our heart rate goes up. We exhale, our heart rate goes down. Why it happens? So heart rate increases during inspiration and decreases during expiration. Why? So that was the question. So there are some theories that lung inflation inhibits cardiac vagal afferent activity and evokes tachycardia. If you remember, I have shown there is a vagal nerve from the brainstem that innervates the heart. So when the lung inflates, it inhibits the cardiac vagal afferent. And it actually paces the heart. The heart rate goes up. So the opposite happens during the expiration. The activity of the afferent cardiac vagal nerve reaches its maximum, thus extending the RR interval. So I will discuss what is RR interval here. So so during expiration, our heart rate goes down. So, and it is the opposite of the RR interval. I think Jesif mentioned at the beginning what is HRV and how we collect it from the electrocardiogram, ECG. So in the ECG, if you remember, you have this PQRST, that QRS complex. So we have the R peak. So the distance between the R peak is actually considered this RR interval. So this is actually used for detection of heartbeat mostly. So, okay, so there's a benefit, like why nature has given us this, thing. It's because there is a benefit. This is how human body works, or even human life, right? So the match a timing of alveolar ventilation and its perfusion with RSA, as I mentioned, respiratory sinus arrhythmia, within each respiratory cycle could save energy expenditure by suppressing unnecessary heartbeats. Heartbeats during expiration. So, so there is a benefit of this synchronization. That's why we have it. This is the reason why our heartbeat actually synchronizes with respiration. So with respiration, we can actually control our the rhythm of our heart. Okay, so I have something for you. I don't know if you will listen to the sound, if you can hear the sound. So here, I want you to breathe along the sound or along the, this this pattern. Let me explain it to you how it works. Can you hear the sound, the music, or you cannot?
Not clearly. No, we cannot hear. Because
Okay.
your audio source has been selected as your microphone, not the aux input, not the output of your system. So you need to go to the audio setting. Yeah, one second. Yeah,
Yeah, sorry. Yeah, I could not unmute myself, so I had to
yeah,
wait
yes,
for you.
yes, yes, yes.
Okay, okay. Yeah, okay. I think if you cannot hear the sound, that's fine, because this is very interesting. So what you have to do, just follow the rhythm and just breathe along the. So now inhale, now exhale, now inhale, now exhale. Let's do it for a few seconds. Now inhale. Okay, I'm feeling good now. I think you have to do it for, like at least for 5 minutes. And actually, a lot of things happen. Like when you breathe with this particular rate, your heart rate changes, and a lot of, things actually change within you. So we can actually quantify it using signal processing techniques. So that's the beautiful part of this. So here you can see this is a 5.5 beat per minute uh, audio signal. So if you convert it to frequency, it will be like 0.0917 hertz. So the person is, uh, so we guide the person to breathe at this particular rate. So there is something called Meyer waves. That is the blood pressure waves that we have. So our blood pressure wave actually oscillates at 0.1 hertz. That is pretty close to this frequency. So what happens? Like there are some theories. So when we breathe at this particular rate, there is a resonance that gets created, and it actually maximizes the, what can I say? There is something called low frequency power in the HRV, which gets amplified because of this resonance. So I will get back to that. So this is what people actually use for reduction of stress. So they call it heart rate variability breathing techniques mostly. Uh, okay. Okay. I think I mentioned about the RSA. What is RSA? So there's something called baroreflex. So why our heart rate goes up and why our heart rate goes down when we inhale and exhale? So if you can see this image, so we have in our brainstem, there is an area called nucleus bracteus solitaris. So here it's our heart, and these, these these green dots are actually, they are baroreceptors. So these are certain receptors in our, uh, you know, uh, arteries and veins that actually senses the blood pressure. So this is, these are like, this is sensor. So this senses the blood pressure, and it sends the signals to our nucleus tractus solitaris, and which in turn sends signals to our heart, whether it can be parasympathetic or it can be sympathetic. So when our blood pressure goes up, it slows down the heart, right? And when blood pressure goes down, the heart starts to beat faster. So this mechanism is very interesting, and it again releases those acetylcholine and adrenaline and those neurotransmitters, which actually uh, changes the speed of the heart. So this is the mechanism, like how these things actually happen. Okay, now let's deep dive into the uh, you know the signal processing part of heart rate variability. So first, we need to understand what is heart rate variability. Uh, so Jesif already mentioned, like, we use mostly electrocardiogram to get our heart rate data. So in my analysis, I use something called pulse plethysmogram. I will talk about it. So this is the EPG signals. So here you can see this is the ECG signal, ECG trace. So we have this P wave QRST complex. So you can see, these peaks actually mark the onset of the heartbeat. So there is a difference. The difference between the peaks is actually written down as RR interval in milliseconds. So between the first two beats, it's 828 milliseconds. Between the next two beats, it's 845 milliseconds. So our heart is not beating like a metronome. It's not like the tick of the way the clock is ticking. It's quite complex. The difference between the heartbeats, timing difference between the heartbeats is changing over time. So sometimes it's 828, the next one is 845, and so on. So there's there's an advantage of having this kind of abnormal, uh, I won't say abnormal, but this kind of variability. It helps our heart to adapt to different situations very effectively. If it is it's like a metronome, there's no change, then it cannot adapt to the different situations. But it's so quiet because it is complex and it is changing. It is quite variable, so it can adapt to different situations. So yeah, so this is what our heart rate variability mostly is. The temporal variability of the heartbeats mostly. So that's what is heart rate variability. Okay, so, and if you have questions, you can also ask me now. That's also fine. You can feel free to interrupt me. So let's talk about the HRV measures. So there are different measures that we can consider while quantifying the heart rate variability. So we have time domain measures, we have frequency domain measures, and we have nonlinear measures. The time domain measures are like, they mostly quantify the the variability in the time domain. So these are the time domain measures of heart rate variability, which are most commonly used. So we have the most important one is SDNN, just the standard deviation of the NN intervals. They call it NN because these peaks are assumed to be normal, but they are pretty they're normal. They're not. There's no motion artifact in it, so they call it normal NN mostly instead of RR. Again, you can also call it SDRR. Then we have RMSSD, that's the root mean square standard deviation of the RR intervals. So these are the intervals, and you just do the mathematics over it. So this is the simple mathematics. You take the root mean square standard deviation of those RR intervals. And we also have these matrices like NN50. I won't go deep into those right now. We also have heart rate maximum, minimum, some triangular indexes, etc., etc. They can actually give us a lot of information regarding, if there's any cardiovascular conditions, like there's some pathological conditions in the heart and all that. Okay, so this is the definition. The time domain indices quantify the amount of variability in the measurement of the interbeat intervals. So these are called the interbeat intervals. These are RPs, mostly. The difference between the RPs. And then we have the frequency domain analysis, where we do FFT or wavelet transform or whatever. So we have different frequency bands. The VLF is the very low frequency band. Then we have the low frequency band, and then we have the high frequency band. In my analysis, I mostly focus on LF and HF. Okay. Okay, I will just read it loud, like what it is. So slow breathing actually activates both CNS and PNS and increase RSA. So why we do slow breathing? To reduce the stress. So there are some reasons behind it. And this is very interesting. The oscillations of a healthy heart are complex and non-linear. So that's why we can use non-linear dynamic techniques to quantify the heart rate, the working of the heart rhythms mostly. So reduction in the complexity of a physiological or behavioral control system with age and disease. So with age, actually, the complexity of the heart changes. So, some of the things, the HRV of an, old person and HRV of a young person is quite different. I already mentioned about these things. So we have a vagus nerve and the sympathetic cardiac nerve that actually controls the heart rhythm. So this is interesting. So I found this analogy. It's like a racing car. So when you take a sharp turn, you put your leg on the brake as well as on the accelerator. So you are both accelerating and both, at the same time you are braking. So in the same way, your parasympathetic and sympathetic nervous system are working together. So it's working together. It's not that one is dominant over the other. Okay, so now let's do some signal processing things. So this is what, so I'm using photoplethysmogram instead of ECG. So this is another technique that can be used to, quantify the heart rate variability. So it's an optically obtained, ECG is an optically obtained plethysmogram that can be used to detect blood volume changes in the microvascular bed of tissues. So when we have the capillaries, right? So we put the sensor in our finger. So when the heart pumps, then there is more blood in it, right? So there is more blood flow during that within that area. So this photoplethysmogram has an LED and it has a photo detector. So the LED emits the light, and the amount of absorption get distorted because of the heartbeat, because there is more blood flow, and that distortion is actually detected. So they call it blood volume pulse. So you can see here. So it's like one of my previous studies. So you can see those green dots are actually heartbeats. So this is how the PPG looks like. So you can use some algorithms to detect the peaks. Like in MATLAB, you can have some peak detection algorithms. For ECG, you have this Pan-Tompkins algorithm. For EPG, it's different. So you can use some moving average filtering to get those desired peaks. So there are some toolboxes in Python, if you use Python, which you can use. So I actually found this toolbox very useful. Okay, so now we have these peaks. Okay, let me go back. So we have these peaks right now. Now we will do the analysis. This is actually part of my experiment. So this is the respiration data. So you can see here, the person was breathing at a very faster rate here. You can see this sharp, this frequency is high here. So the person was breathing at a very high frequency. And here the frequency is low. So the person was breathing at a faster rate, and sometimes the person is breathing at slower rate. So we will do a comparison between them. So this is what I will show you in this talk. All right. So yeah, so there are some publications that I would like to refer to. So this is an interesting paper. So talks about the effects of breathing patterns and light exercise on linear and nonlinear heart rate variability. So if you remember, our talk started with stress and the techniques to reduce stress. So one of the techniques that we can use to reduce stress is the different breathing techniques. So people have studied the breathing patterns and how it actually affects your linear and nonlinear heart rate variability. So what they found, this is the power spectrum of the RR intervals. So this is a frequency domain analysis of HRV. So you can see here, when the person was breathing at 0.1 hertz, you can see there's a peak at 0.1 hertz. So if the below is a 0.1 hertz here. So and again, you can see here when the person was breathing at 0.2 hertz, and there is a peak at 0.2 hertz. And this is not the respiratory peak, it is the peak in the RR interval, that's the HRV. So this is interesting. So it means that our respiration is actually affecting our heart rhythm. And if you convert the 0.1 hertz, just to make a sense of it, it is the 6 breaths per minute. So you are inhaling and exhaling. So one inhalation and one exhalation is considered as 1 breath. So you have 6 breaths per minute. So in 1 minute, you are breathing at 6 times. It's very slow. And sometimes actually I do it. So it slows down your heart rate, and there'll be person to person variability. Some person might not show substantial effect, but some might show. So that is always there. Okay, so this is what the frequency domain analysis looks like. Okay, so I didn't mention, like, the person was resting and the person was doing some dynamic exercise, and then they collected their heart rate variability data and then did this frequency domain analysis. Okay, so there's another paper. It's called Relaxation Effects of Musically Guided Resonance Breathing in a Randomized Control Pilot Study. So this, actually, I'm following this study for my present study. So what they did, they used in slow breathing intervention as well as a guided music therapy, and they looked at whether it can reduce stress. Yeah. So if I'm running out of time, feel free to let me know. I'm actually not keeping track of the time. Yeah. So this was their study design. So what they had, like, they had a baseline where the person was not doing anything. Then they had a stress task. I forgot what was the stress task. It can be scary movie, or maybe, like the exams. The student is study, in the exam hall. That can also be a stressful event. And then there's a post task. Then we have the intervention and the post intervention. So stress task was, and then what they did, like during the baseline, they took a visual analog scale. So this is like questionnaires where they ask people to rate, like how they're feeling and all that. Then they measure the HRV, and during the stress task also, they measure the HRV, then they took the visual analog scale. And after the stress task, they apply the intervention. The intervention can be the breathing that we have been discussing throughout this talk. It can be slow breathing, right? And it can be in music also. Like we listen to music, so music can also be an intervention. And then we have the post intervention. So they just recorded the results. And what they found that the mean heart rate goes up during the stressful events. So when we're stressed, or then our heart rate goes up. So before the exam, you feel, anxious, or even before the talk, my heart rate goes up. And then eventually it goes down. So you can see in the intervention, it actually went down. And then in the post-intervention, it went up a little bit. So this is mean heart rate. So you can also calculate the heart rate from the PPG or the ECG signals. So that's pretty straightforward signal processing. Okay. And this is one of the parameters of, if you remember, the time domain parameters of HRV that I already discussed. So this is one of them. It's called the root mean square standard deviation of the RR intervals. So here you can see in the baseline, it was like around 45. And then in the task, it went down. And in the intervention, it went up. And in post-intervention, it went down. So this is very interesting because heart rate variability and optimize a high heart rate variability is a marker of good health. If your HRV is higher, it means your heart is working fine. You are not having any pathological condition. But if it goes down, it means that there is something wrong. I'm not discussing the clinical aspects of it mostly. So if you look at the clinical literature, you will find for even heart attacks and all that, HRV goes down, all those things happen. So our goal is to increase the HRV, heart rate variability. How can we do that? Using an intervention, right? And that intervention can be slow breathing or it can be music or whatever. Even with music, you can see here in the control group, it actually went up a little bit. And then again, it almost remained the same. But for the slow breathing, it actually went up. So this is really interesting. And I saw this in my studies, so it was really good. Yeah. So this is what people have done already. So I can show some of my own results. So I did a study. I won't share some my present research right now because those things are not published. This is something that I did a few months ago. You can see there is a peak around 0.08 hertz here. So the person was breathing slowly and slowly at a rate of 5 breaths per minute. So if you convert the 5 to frequency in hertz, you will find that it will be 0.08 hertz. So we can see a peak at 0.08 hertz. And here, the fast breathing, there's a peak around here. It was 0.33, I guess. But there is subjective variability is always there. For subject 2, it is a bit different. Here you can see the slow breathing is apparent. For the first fast breathing, the peak is pretty high here. Not actually high, you can see it's 10 to the power minus 3. The amplitude is lower. Yeah, although apparently it looks like it's bigger. It's just a Fourier transform of the RR intervals, but there are some standard procedures that you have to follow. For example, you have to band pass the signal using whatever filter you like Butterworth or whatever, and then you have to you have to interpolate the signal. You have to resample it, and then you can do the FFT. And it is quite straightforward. You can use MATLAB or whatever toolbox you want to use. And these are some nice plots. This is time frequency plots. They call it waterfall plots. You can see, when in the slow breathing condition, and there are a lot of peaks during in around 0.08 hertz in the slow breathing condition. And the fast breathing, it's quite scattered. There's no prominent peak in the low frequency band. So if you remember, I mentioned that there's a low frequency band and there's a high frequency band. Let me quickly show you. Here, 0.04 to 0.15, these are called low frequency bands, and then we have high frequency bands. Purple color corresponds to low frequency band, and Arctic color corresponds to HF band. So, yeah, here you can see these different colors represent different bands, All right, so, and I also plotted the time frequency plot. Here you can see, around 0.08 hertz, there is a very, very nice activity in your HRV. So this is the low frequency activity that is prominent during the whole duration. Okay, I just plotted for 1 minute of data, I guess, here. So it's like 60 seconds of data, but you can see it's very prominent here. It's very beautiful when you do this analysis and see those results. Okay, so I am I'm almost done with my slides. So okay, this is all about the signal processing part. So if you have questions when I'm done, you can feel free to ask me questions. I would love to answer. So what are the ways to cope with stress? So cognitive behavioral therapy is most frequently used. Stress management intervention. I've never done cognitive behavioral therapy. So what it does, what I found by reading, it actually changes your thought patterns, because our thoughts actually affects our emotions. and emotions affects our behaviors, and and then we have physical sensation. So it can change your thought pattern from negative thoughts to positive thought, and it's actually very wide. Uh, it's an umbrella term, and a lot of things. I would say it's a very broad subject, cognitive behavior.
Very good evening to everyone.
Yeah. So, and then we have the music therapy and the deep breathing. And in my talk, I explained the deep breathing, slow breathing techniques mostly. So this is the effect of slow breathing. In a 0.08 hertz, we can see the activity in our HRV signal. So that's so this is, remember, this is, we are breathing at this frequency, but this is not the respiratory signal. This is the heart rate variability signal. So this is what we see in the heart. So there is an interaction, there is a bidirectional interaction that is going on between the heart and the respiration. So this is there's a very interesting, nice term that mostly neuroscientists use. It's called entrainment. So entrainment means when we have two oscillators, two oscillating systems, and then they become coupled. That process is called entrainment. Here also we have the heartbeat that is going on by itself, and then we have respiration, that is another independent oscillator, and then these two systems interact. So they are entraining each other mostly. So that's why we're seeing this very nice activity. Okay, so this is, and then we know that this deep breathing actually works, and it can be used as a stress reduction mechanism. Okay, I did not say this thing. So when you do this kind of meditation or breathing techniques, your cortisol level goes down. So this is one of the markers, and also your heart rate variability goes up. So these are the markers that says that actually this kind of intervention can be effective in stress reduction. Okay, and this is my last slide. So, and this is one of my favorite subjects, the evolutionary biology. So why do we have stress, right? Is it really bad? Before the exam, if you don't have stress, you are not going to study, right? So this is important. So stress is important, but chronic stress is not good. So that's why we have to use those interventions. So this is a paper that I found, I read yesterday. So evolutionary origins and functions of the stress response. So I won't go into the paper, but I will just read aloud some their final paragraph, and it will be very clear. So we think of these demands as coming from the outside. I mean, these stressor things, they're calling it as demands. And sometimes they do, as when we are attacked by the proverbial tiger. So assume we have a tiger in front of us. But most stresses in modern life arise not from physical dangers or deficiencies, but from our tendencies to commit ourselves to personal goals that are too many and too high. We have too many goals and too high aspirations, right? So when our efforts to accomplish these goals are thwarted, or when we cannot pursue all the goals at once and must give something up, the stress reaction is expressed. In short, mass stress arises ultimately not from a mismatch between our abilities and the environment's demands, but from a mismatch between what we desire and what we can have. So what they are saying is that it's our unending desires, and mostly that actually keeps us under constant stress. So it's can food for thought for us, and we can always contemplate on this evolutionary origins and aspects of the stress. Yeah, that's all what I have for you. So if you have questions, I would love to answer. Thank you.
Thank you, Debanjan, for such a wonderful session. We have few questions, and if anybody has more questions, they can put in the chat box, or you can unmute yourself also to ask the question. So you can just raise your hand. So the first question is, can we reduce stress through meditation?
Yeah, this is what I have said, right? There are different kind of meditations, right? Like we can, like the one that I mentioned here, the slow breathing, is also a part of the meditation techniques. Like, in India, we have the pranayama, different breathing alternate nostril breathing. things. So it can actually reduce stress, and there are evidences. I have already shown you some evidences that heart rate variability goes up when you breathe, you know. And there are other meditations like mindfulness meditations, or maybe those are also helpful because you learn to control your mind. So you become more calmer, you know, and more, yeah. So the answer is yes.
Okay. In another question, the participant has asked to prescribe some drugs or medicine to reduce stress. But I don't think that in this current webinar it will be possible to prescribe some
No,
drugs.
yeah, exactly. We cannot prescribe anything, but yes, there are drugs people use. I have not, I'm not familiar with them. Like there are some beta blockers and like those kind of drugs are used.
Okay.
You know, they can slow down your heart. I mentioned about the acetylcholine and norepinephrine neurotransmitters. So those drugs actually blocks those, you know, neurotransmitters and then give you a feeling of uh, low stress condition. But I personally, on my personal note, I personally prefer not to use medication unless that is extremely, you know, necessary.
Okay. In another question, the participant has asked, have you checked the effect of music therapy on lowering of stress? Are there any known studies on this aspect? Also, if you have any information about what type of music is more useful in bringing stress level down.
That's a very good question. I don't know who asked this, but this is really good question.
This is from Bikramjit sir.
Okay, thank you for this question. This is actually one of my interests too. So in one of my studies, I'm comparing relaxing music with slow breathing. Like how, you know, which one is more effective in reducing stress. Yes, there are different kind of musics, and there are plenty of research papers available. You can go through them that have found that music therapy can actually effectively use to reduce stress. When you say music therapy, it's not like listening to music. There will be a music therapist, which is actually, you know, certified music therapist. We will play the music in front of you. And what kind of music, right? That's an interesting research question. It is found that slow tempo music is mostly used, and you know, not like, you know, rock songs or like, you know, those kind of songs, they won't work. It's like slow, you know, tempo music mostly used, and they have some other aspects too, but that's another research question, and that's a very good question. It can reduce stress. Yeah, there are documented publications on it. It can actually reduce stress.
Okay. I think Saurav wants to ask some question. Saurav, please go on.
Yeah, I'm connected. I hope, sir, you can hear me. Hello.
Yeah.
Yeah, sure. So I would like to ask you a small three questions from my side. That can we use the oximeter to measure the PPG? Is it somewhat similar or it is completely different?
Yeah, I think it's similar. I have not used pulse oximetry devices. It actually measures the oxygen saturation in your blood.
Okay. Yeah.
But the mechanism is
I know
similar.
some of the preliminary, but I am not exactly accurate about the information. So do you have
Yeah,
any
that's a
idea
good
on
question. I right now I don't know the difference between pulse oximeter and PPG devices, but the technique is same. It actually measures. You know, it is sends the you know, it sends a light and it gets reflected, and the amount of absorption is reflected as, you know, your oxygen saturation or as a blood volume pulse. Yeah.
Okay. I have one more question. That can music therapy be used to reduce some of the symptoms of type 2 diabetes mellitus, which is one of my area, where we can find the patients are suffering from ventricular hypertrophy and ventricular, I mean to say, tachycardia or peripheral neuropathy. This sort of symptoms, can music therapy be a solution to
Yeah,
this?
I think there are evidences that I'm not sure about diabetes.
Yeah.
Diabetes, but as you mentioned, some of the symptoms, right, like the this ventricular tachycardia and all that. Yeah, so you know, there are studies that have found when you are listening to music, like classical music or, you know, calming music, soothing music, relaxing music, your heart rate goes down. You know, so yeah, definitely it will have some effects, but that is very interesting. I know if you are interested, you always explore like how music goes to our brain, right, when we hear. and then it modulates our heart rhythm. How it happens, that's a very interesting topic, and I don't know much about it, but it explodes.
And one of the last question that I would like to ask you, that you have in your slide, you have used a blue color bar. I think you have done the simulations in the MATLAB. So in the right hand side, there was a, really don't know what's that bar exactly measures. I can understand the color gradients for representation of the
time frequency?
Yeah, I mean this column in the right hand side, because I was trying to find out and I couldn't find out that accurately.
It is just
Do you have any idea?
It's a color bar. I think.
Yeah, a color bar I understood, but can you tell what there is the intensity of 10 to the power minus 3 in there? Do you have any idea? Actually, I failed to find out, and I didn't get proper answers in the MATLAB. So, do you have any idea? Because that's one of the fundamental that I need, and I failed to find out.
So you could not have that color bar in your plot.
I could have it, but do you know what that exactly means? I mean to say,
it's actually just it's actually, for example, it depends on, for example, I'm doing the low frequency power, right? This is what so this is your low frequency power in my case.
Okay, power intensities.
Power intensity, the color represents the power intensity. Red means it's more power. It's like whatever color you are using.
Okay. Thank you, sir. Thank you so much for this answer.
Welcome.
Okay. Another participant has asked for some live practical MATLAB programming for signal processing, but I don't think so that it will be possible in this current webinar to cover all those. I hope that Debanjan will be able to share some basic programs for signal processing via email so that I can share with the participants.
Yeah, why not? Yeah.
That's all. If anyone has asked to ask, wants to ask any question, they can unmute themselves and come to the floor. Anyone? You can just unmute yourself and come to the floor for asking any question. If there's no question, we can conclude the session.
Good evening. Am I audible?
Yeah.
Yes.
Okay. It was a real pleasure to listen Mr. Debanjan Borthakur, who is a scientist and as well as an entrepreneur. If I'm correct, he is the co-founder and CTO of AI Yogi.
Okay, thank you. Yeah. We just started this. Yeah.
Yeah, I have just found out. Okay. So he had explained so nicely the relation between heartbeat and the respiration, and thereby also showed how slow breathing techniques can reduce stress. And also it is very encouraging to see that there are measurable metrics available in this regard. Again, HRV was, and its importance was nicely explained in terms of the RR interval. Again, regarding the signal processing part, it is very encouraging to see that different techniques such as the time domain, frequency domain, as well as the nonlinear techniques are used in this regard. I'm sure that the students, researchers, and the faculty members, those who are present, will be immensely benefited from this talk. I would like to take this opportunity to thank Mr. Debanjan Borthakur for taking out time of his busy schedule to prepare this lovely talk and present it so nicely. I would also like to thank our HRV ma'am for always being the guiding force. Also, a special thanks to Jesif sir for conducting this wonderful event, and thanks to all the faculty members for their cooperation. And I would also like to thank all the participants for taking out their valuable time for this event. I'm sure all the participants are immensely benefited from this event. Finally, from all of us, we would like to say a big thank you to our research person and wish him best of luck for all his future endeavor. Thank you all and have a nice evening.
Thank you, Jyoti. Thank you.
Thank you. Shakuntala ma'am, would you like to address with a vote of thanks?
Okay, very good evening to everyone. So let me first of all express my sincere thanks to Debanjan Borthakur, researcher of McMaster University, Canada, for his wonderful talk and the very impressive interaction. Department of Assam Bosco University will be always grateful to you for readily accepting our invitation for this webinar in spite of your busy schedule as researcher. Thank you, Debanjan. I take this opportunity to thank all the participants and also our Vice Chancellor, Father Stephen Mavely, our Director, School of Technology, Manoranjan Kalita, who always support and inspire in our every academic endeavor of the department. And I also would like to acknowledge the wholehearted work of Mr. Jesif Ahmed of our department for his efforts and hard work which he has put forward to make this webinar successful. Thank you, Jesif. Thank you very much, all.
Okay, thank you everyone. Thank you for joining. Thank you, Debanjan. We hope to connect you again in future.
Yes, certainly. I will also look forward to connecting with
Yeah.
you again.
Yeah.
It was really my pleasure, and I really enjoyed also the interactions and kind of questions that I got. Yeah, I think it's really encouraging, and yeah, I will look forward to discussing more on different topics, mostly neuroscience and these kind of things.
Thank you. Will you be able to share the slides with us? Is that possible?
Yeah, I think I can share the slides with you. Yep.
Thank you so much. Thank you so much. So everyone, will end the session here for today. Thank you again, once again, for joining us, and all the best. Be safe. Thank you.